Hey class, today we're going to go over the rest of our 1.3 notes for college algebra, which is doing some word problems, application problems. In the last lesson, we went over the first three examples. We're going to start with example 5, which is this one. So it's a little bit more involved than the other ones. We're going to try to take this step by step. Your grandmother needs your help. Let's help our grandma. She has $50,000 to invest. Part of this money is to be invested in non-insured bonds, paying 15% annual interest. I'm going to start highlighting pieces of information that sound important. So she has $50,000 to invest. The bonds, non-insured bonds, pay 15% annual interest. The rest of the money is to be invested in government-insured certificate of deposits, paying 7% annual interest. So we have two different accounts. She has $50,000 total to invest, and she needs to split it somehow between the two accounts. She told you that she requires $6,000 per year in extra income from the combination of these investments. How much money should be placed in each? So there's a lot going on in this problem, and eventually we want to get to the point where we can form an equation and solve for a variable. But trying to go from a word problem like this straight to an equation sometimes is like ridiculously difficult. And really, no one expects you to be able to do that. So what I want to kind of go over are some tools to help you learn how to problem solve here. One of my favorite tools for problems where there's this much information going on is just to make a table and kind of play with the numbers a little bit. So we're going to start by making a table. We have two different types of accounts. We have the bonds, which is 15% interest, and we have the certificate of deposits, which is 7% annual interest. And then we want to end up with $6,000 per year out of the interest from those accounts. So I want to know what the total interest is going to be. Now remember, we have $50,000, or Granny has $50,000 to spend total. So let's just start by playing around with these numbers and see what happens. So if I invest, let's just split it in half. See how that works. So if I invest $25,000 in the bonds account, and then the other $25,000 in the certificate of deposits, in order to calculate the interest, how do we find what 15% of $25,000 is? We multiply by 0.15. So, and here, 7%, we're going to multiply by 0.07. So if we find those individual pieces, so I'm going to kind of write those over here. I wish I had, well, let's see. Let's just write it below. So 15%, 25,000 times 0.15, using my calculator. We have 3,750, and 25,000 times 0.07 is 1,750. If I want to know how much total interest I'm getting from these investments, think about what are you going to do with these two numbers? Well, we would add them. So I'm going to add these two numbers together, 3,750 plus 1,750. I end up with $5,500, which is close to the 6,000 she wants, but not quite there. So we can keep doing this a couple more times, but keep in mind that our goal is to kind of figure out an equation. So see if you can start seeing some format, some equation formatting happening here while we play with the numbers. All right, so the next, I don't know, let's see if we need more money than that, then we probably want to put more into the account with the higher percent of interest. So let's try 30,000 here. And if I have 30,000 in the bonds account, then how much do I have left to put into the certificate of deposits? How do you figure that out? Well, if we have $50,000 total, then that leaves me with 20,000 to put into the certificate of deposit. So now let's see what we get here. 30,000 times 0.15 gives me 4,500, and 20,000 times 0.07 gives me 1,400. If I add those together, I end up, oh, I'm so close. I'm so close. Now we can keep doing this. Let's just see if I get, let's go another 5,000. Let's do one more shot, see how close we can get, or if it goes over or what happens. So let's try 35,000. And how do we figure out how much is left? We subtract from 50,000. So 50,000 minus 35,000 gives me 15,000. So 35,000 times 0.15 plus 15,000. Oh, I guess I can write that part down. We've got 5250 and 15,000 times 0.07 is 1050. If I add those together, 5250, I get 6,300. Now we've gone over. So I kind of have an idea of what these numbers are going to be between for each one of my investments, but we definitely need to come up with an equation. I don't want to sit here and just keep guessing and guessing and checking because it could be some weird amount with pennies and I don't know. I want to make sure that we get the exact amount. Now you might be thinking, well, why can't Granny make more than $6,000? That would be nice. But when you're investing money, the higher the interest, the higher the risk. And so we really don't want to risk more than we have to with Granny's money, but we want to make sure she gets to that $6,000. So start looking at the table we made and see if you can find a pattern. So if we want to find an equation, let's look at this. It looks like whatever we choose here, let's just make it X. For our initial investment, anything there is going to be multiplied to 0.15. And then we added it to, and now this part's a little trickier. How did we get that second number depending on how much we put into the bond account? Well, we took that and subtracted it from the 50,000. So we've got $50,000 minus X. So minus whatever we put over there. That's multiplied by 0.07. And then that equals, we want it to be equal to $6,000. So we're going to set it equal to 6,000. And this is a pretty complicated equation. It would have been difficult to jump straight from the words to this equation. So using tools like the table of values and just kind of playing with the numbers and seeing how they work together can really help you go from a word problem to finding the equation. All right, so now we get to solve. So let's see, I'm going to take this equation and I've got 0.15x plus, and then I'm going to multiply this in here. So 50,000 times, let's see, 50,000 times 0.07 gives me 3,500 minus 0.07x equals 6,000. Now remember, X in this case is going to be whatever we put into our bond account, our 15% bond investments. I have like terms here. So 15 minus 7 is 8. So 0.08x plus 3,500 equals 6,000. I can subtract this to the other side. 0.08x equals, let's see, 60 minus 35 is 2,500 divided by our 0.08. And x is, let's see, 2,500 divided by 0.08 is 3,150. So now, because it's a word problem, we want to make sure to write our answer in context of the problem. And actually, we're not quite done, but we're almost there. So if that's $31,250 into the 15% bond account, then how much is she going to put into the certificate of deposit account? Well, we would just subtract that from 50,000. So 50,000 minus 31,250 is 18,750. So there's our other answer. Make sure you reread the problem and figure out exactly what they want you to answer so that you don't forget one of your solutions into the 7% certificate of deposit account. All right, and that was a big word problem. So that's that one. Let's go to the next page. We have just a couple more things to cover here. Switching gears into more of a geometry problem. The length of an American football field is 200 feet more than the width. If the perimeter of the field is 1040, so 1,040 feet, what are the dimensions? So a couple important things here. I know that the length is 200 feet more than the width. So now I'm going to do this really quick, more than. So we have to be careful about exactly what that's saying. And then the perimeter is 1,040 feet. So a couple things I know. I can take the first equation and write, or the first sentence and write an equation with it. The length is 200 feet more than the width. So if I just took that first sentence and rewrote it, that's what it would look like with symbols. And then the perimeter is 1,040 feet. So we have some equations here. Perimeter of a rectangle. So American football field is a rectangle. Perimeter is 2 times the length plus 2 times the width. All right. So now we can kind of use this format and input this 200 plus W into L. So do a little bit of substitution. So 1040 equals 2, and then instead of L, I'm going to substitute it for 200 plus W plus 2W. So this is one way to do it. You could have also taken half the perimeter, which would be 520, and then only done 1L plus 1W, which I can actually get to right now if I wanted to divide everything by 2. This is a little trickier. There's a lot of ways we can solve this problem, but that would take it down to 520 equals 200 plus W plus W. So just one of the lengths and one of the widths. You can also distribute the 2 into those parentheses and just solve for your variables. There's lots of different ways you can go about this. All right, so let's subtract 200 to our other side. We have 320 equals 2W, divide by 2, and that's going to be 160. And our units are feet, so width is 160 feet, but it asked for the dimensions, so I also want the length. Remember, length is 200 plus W, so I'm going to take 160 plus 200, and I get 360 feet. All right, so this problem was a little easier than the last one. Okay, and then the last piece of our lesson here, solving for a formula for a variable. So really what I'm doing is I am isolating, let's see, the formula, so the variable is isolated on one side of the equation. We're not actually going to obtain a numerical value for the variable. We're just going to get the variable by itself. So if I need to get L by itself, then I need to start moving things away from the L, and it's easiest to move things that are least connected to it. So for example, if I start with P equals 2L plus 2W, and I always do my L's cursive so they don't look like ones. The 2W is the least connected to the L. So I'm going to have P minus 2W equals 2L. Now, the only thing to get rid of is that 2 being multiplied to the L. I can get rid of the multiplied factor by dividing it through. So P minus 2W divided by 2 equals L. You can also write this if you took each individual piece and divided by 2 as P over 2 minus 2W over 2. And then these 2's actually cancel out. So I've got P over 2 minus W equals L. And I'm fine with either one of these answers. I don't think one is simpler than the other, so whatever you prefer to go with is just fine. Last example is a little tougher. We have our formula for interest, really. So we have principal amount, P in dollars worth after T years when invested in a simple annual interest rate R. So we want to solve this formula for P. Now it's a little more difficult because there's 2 P's, and we have to figure out how to make those 2 P's into 1 P, even though they're not like terms. Now this takes a lot of brainstorming and a lot of trying things out. which we do during class together. But to make this video short, I'm just going to kind of jump to it. So to get the p's together, we can factor it out. So it's a little trick here. I can factor the p out, and then what would be left? So I want to think about, like, if I were to distribute this back in, I'd want to get a p first. So I need p times 1 plus, and then what do I need over here to get a PRT? Well, I need an RT. So factoring the p out would give me this equation here, and I'm going to just erase those pieces. Now to get p by itself, I can just divide by this entire quantity. 1 plus RT. And again, I do a little hook on my t's so that they don't look like plus signs. All right, so we end up with p equals, because this cancels out entirely, a all divided by 1 plus RT. All right, so once you figure out that trick about factoring the p out, it's not too bad, but thinking about that is a little tough. These aren't really easy things to do. All right, and that's it for our lesson today.